Astronomy, Unit 1.1, Celestial Sphere Basics. Look up at the night sky. What do you see? You probably see a bunch of stars. There are bright ones, dim ones, large ones, and small ones, although there really isn't a difference in size from where we are. However, all of these stars look like they're attached to a sphere going around the Earth. That, my friends, is called the celestial sphere. This is a model that involves using a globe of stars around the Earth. It's not necessarily an accurate representation of how things actually are, but it can be very useful. Yes, we know that there's no imaginary sphere of stars around the Earth, and we know that the Earth actually rotates around its axis, but is that model really useful for locating stars and constellations, from our standpoint? Although it's technically an incorrect model, it's very useful for locating stars because the celestial sphere is like a coordinate system. Why don't we take a little look at it? If you take a look at the celestial sphere, you see a grid with horizontal lines of declination and vertical lines of right ascension. Declination lines measure north and south and have a celestial equator. If you measure north, you're measuring in a positive direction, and it's opposite if you're measuring south. Right ascension lines measure east to west in units called hours. An hour is equal to 15 degrees. Okay, so we learned today that stars are mapped on the celestial sphere and they are marked by lines of declination and right ascension. For example, Betelgeuse is at around 5 hours and 56 minutes right ascension and positive 7 degrees and 4 minutes declination. That's it, folks. Thanks for watching. Next lesson we'll learn about how we relate to the celestial sphere. Bye!
Created using Powtoon.